You are standing on the edge of something extraordinary. Imagine this. For centuries, humanity has gazed at the night sky, mapping constellations, tracking planets, and dreaming of distant worlds. Yet, even as our telescopes grew sharper and our spacecraft reached farther, we thought of space as open, endless, and unbound. But then something changed. Something invisible, something almost unreal, began to reveal itself. A mysterious boundary, an invisible wall, a cosmic shield that seems to guard our solar system. Now pause for a moment. Picture yourself floating beyond Neptune, far past the icy plains of Pluto, moving into a realm where the sun is nothing more than a bright star in the distance. You are drifting into interstellar space, the cold, dark gulf that separates our star system from the billions of others in the Milky Way. But before you can leave, before you can escape the sun's influence, you encounter resistance. Not a solid barrier like a brick wall, not even a faint shimmering curtain. Instead, you sense an unseen boundary, a pressure, a wall that isn't really a wall at all, yet is powerful enough to shape the path of cosmic rays, to deflect galactic winds, and to guard the solar system itself. Scientists first caught hints of this boundary decades ago. They called it the heliopause, the outermost edge of the sun's magnetic bubble, known as the heliosphere. Think of the heliosphere as a giant protective cocoon inflated by the constant outflow of solar wind. This invisible bubble shields us from dangerous cosmic radiation streaming in from the galaxy. Without it, life on Earth would be bombarded by deadly energy. The heliosphere is our cosmic shield, but like any shield, it has an edge, a boundary, and it is there at the heliopause that the mysterious invisible wall exists. Here's where things get fascinating. You might imagine this wall as a neat, simple outline like the edge of a soap bubble. But the reality is far stranger. Data from NASA's Voyager 1 and Voyager 2 spacecraft, humanity's only messengers to ever cross this frontier, revealed something unexpected. As they pushed into interstellar space, they recorded sudden, dramatic changes in particle density and magnetic fields. Imagine driving on a smooth highway and suddenly hitting a patch of rough, invisible terrain that shakes your car. That's what happened to the Voyagers. They crossed into regions where space itself seemed denser, where galactic particles pressed in, and where the sun's influence fought back like an invisible current. And here's the part that makes scientists lean forward in their chairs. The data hinted at a wall of hydrogen. Yes, you heard that right. A literal wall made of charged hydrogen atoms, compressed at the very edge of our solar system. This hydrogen glow was first detected in ultraviolet light by the New Horizons spacecraft, the same probe that gave us breathtaking pictures of Pluto. It seems that interstellar gas, colliding with the outer boundary of the heliosphere, piles up there, forming something like an invisible barricade, a cosmic traffic jam of particles. You can feel the weight of the mystery, can't you? Because this isn't just about particles or magnetic fields. This is about the very architecture of our cosmic neighborhood. Why should there be such a dense barrier at the edge of the heliosphere? Is it uniform or patchy and uneven? Does it shift with the solar cycle, growing stronger when the sun is active and weaker when it calms? And what does it mean for us here on Earth, living safely under its shield? Let's make it personal. If you step outside tonight and look up at the stars, you're gazing through layers of protection you never even think about. The atmosphere shields you from meteors and ultraviolet light. Earth's magnetic field deflects charged particles from the sun. But beyond all of that, far beyond your sight, there is this invisible wall holding back a storm of galactic energy. Without it, cosmic rays would pour into our solar system with far greater intensity, damaging spacecraft electronics, disrupting satellites, and even altering the climate and genetic evolution of life. This isn't just an abstract concept. This wall is part of why you're alive, here and now. But like all great mysteries in space, the wall is not fully understood. In fact, every spacecraft that has touched it has left us with more questions than answers. Voyager 1, after crossing into interstellar space in 2012, reported that cosmic rays outside were far more intense than expected. Voyager 2, which crossed in 2018, found slightly different conditions, almost as if the wall is uneven, like a wrinkled shield rather than a perfect sphere. Scientists wonder if our solar system is moving through different pockets of interstellar gas, changing the pressure and shape of this invisible barrier. And here's something even more dramatic. Some researchers suggest that the heliosphere itself might act like a comet, a long, trailing shape with a nose and a tail carving through the galaxy. If true, the invisible wall guarding us is not a neat bubble, but a dynamic, shifting frontier. A frontier shaped by the sun's winds, by magnetic fields, and by forces from beyond our system that we can barely imagine. Think about the poetry of it. Humanity has always longed to explore, to push beyond the edge of the map. Yet here we are in the 21st century, and we are discovering that our solar system itself is wrapped in an invisible frontier, like an island surrounded by unseen waters. You live inside this island. Every breath you take, every sunrise you see, happens within the protective embrace of this mysterious wall. And the deeper we look into it, the more we realize it is not just a wall of particles, it is a wall of secrets. As we continue, you and I are going to travel with the Voyagers, with New Horizons, and with the scientists who dedicate their lives to decoding this invisible shield. We'll uncover how it works, why it matters, and what it might reveal about our place in the galaxy. Because beyond the wall lies the unknown, true interstellar space. And the only way to understand where we are is to understand what protects us. So take a deep breath. We're standing on the cosmic shoreline. Behind us lies the sun, the planets, and the fragile blue Earth. Ahead of us lies the great dark ocean of the galaxy. And in between, a mysterious, invisible wall guarding our solar system. Close your eyes for a moment and picture it. Two small spacecraft, no larger than a family car, drifting silently through the endless black. Their names, Voyager 1 and Voyager 2. Launched in 1977, they were built for a mission that, at the time, seemed almost impossible. Their task was to tour the giant planets, Jupiter, Saturn, Uranus, and Neptune, and send home photographs and data that would forever change our understanding of the solar system. They accomplished that mission brilliantly. But then, after the last planetary encounters, they just kept going. Decade after decade, farther and farther from the sun, until they became our messengers at the edge of interstellar space. And it was there, in that distant darkness, that they encountered something no one fully expected: the invisible wall. You can imagine the engineers and scientists at NASA sitting in control rooms, waiting for faint signals to arrive. It takes over 21 hours for Voyager 1's transmissions to reach Earth. Think about that. When Voyager sends a simple piece of data, it travels across 22 billion kilometers of space before it hits a dish antenna in the deserts of California or Spain. And what do those faint signals reveal? Not just emptiness, not just the slow silence of the void, but sudden, dramatic changes. In August 2012, Voyager 1 crossed into interstellar space. The event wasn't marked by fireworks or flashing lights. Instead, it was recorded in streams of numbers: particle counts, magnetic field directions, cosmic ray measurements. The instruments showed that the density of charged particles suddenly spiked. The galactic cosmic rays, the dangerous high-energy particles that sweep across the Milky Way, grew stronger. The pressure from the sun's solar wind dropped away. In that moment, Voyager 1 had pierced the invisible shield. You have to imagine what that feels like, not for the spacecraft, but for us here on Earth. Humanity, for the first time in history, had crossed beyond the sun's protective cocoon. We had touched the galaxy directly. The invisible wall, once only a theory, became real. 6 years later, in November 2018, Voyager 2 crossed the boundary as well. Its instruments were in better shape than Voyager 1's, so it could measure things more precisely. What it found was even stranger. The invisible wall wasn't uniform. At the point where Voyager 2 crossed, the transition looked different. The density of particles rose in a different way. The cosmic ray intensity didn't increase exactly like it had for Voyager 1, almost as if the solar system's protective shield is wrinkled, warped, or shaped by outside forces. And so the questions deepened. Is this wall smooth or jagged? Is it stronger in some places and weaker in others? Could it even open up at certain points, like cracks in a shield? Here's a thought that keeps scientists awake at night. What if the very shape of the heliosphere, the sun's magnetic bubble, is being sculpted by unseen forces in the interstellar medium? Imagine the solar system plowing through clouds of galactic gas and dust. Imagine those clouds pressing against our bubble, reshaping the invisible wall, creating ridges, folds, and ripples. That's what the Voyagers suggest. The wall is alive, dynamic, constantly changing. Now, let's zoom in on something deeply human. When Voyager 1 crossed the wall, Carl Sagan's famous golden record, a message from Earth containing music, greetings, and sounds of life, also crossed with it. Think about that. Our first artifact to leave the solar system didn't just carry data, it carried a story, a record that says, we were here, we lived, we dreamed, we reached out. The invisible wall wasn't just a scientific discovery, it was a threshold for humanity, a cosmic doorway. And here's something that might give you chills. The Voyagers are still alive. Their nuclear batteries are fading, their instruments are shutting down one by one, but they continue to whisper back to us from the darkness. They are now the farthest human-made objects from Earth, sailing through the void beyond the wall. If you want to feel small, think of this. The light from the sun takes over 16 hours to reach them. Radio signals take almost a full day. Yet those tiny spacecraft are still connected to us, still sending clues about the invisible frontier. Scientists pore over the data, searching for patterns. Each change in cosmic ray intensity, each shift in magnetic direction, tells us something about the mysterious wall. And still, so much remains unknown. For example, Voyager detected something bizarre: plasma waves beyond the heliopause. These are ripples in the interstellar medium, triggered by solar eruptions. It means that even outside the wall, the sun's influence is still felt, like echoes traveling into the dark. So here's the mind-bending part. The invisible wall is not a hard border. It's not like a fence you can touch. It's more like a transition zone, a region where the solar wind and the galaxy collide, clash, and blend, a no man's land of energy and particles. It is here that the sun's bubble ends and the Milky Way begins. And you are living inside it, safely, quietly, unaware most of the time. But when you stare up at the stars tonight, remember, between you and those stars lies an unseen shield. A shield that the Voyagers touched, that they crossed, and that they are still exploring in their silent, patient way. Their journey teaches us something profound. The solar system is not an island floating alone in empty space. It is wrapped in an invisible frontier, a frontier that protects us, defines us, and reminds us that the universe is far stranger than we ever imagined. The Voyagers were the first scouts. They showed us the wall. But now, new missions are being planned. Missions that will map this invisible frontier in greater detail than ever before. And as you'll see in the next chapter, those missions may finally reveal just what kind of shield surrounds our world and why it exists at all. Now picture yourself drifting even farther outward, beyond the orbit of Neptune, beyond the frozen plains of Pluto, and past the realm of icy comets in the Kuiper Belt. Out here, the sun is just another bright star in the distance. But as you approach the frontier, you begin to sense something invisible pressing against you. It isn't a solid barrier. It isn't even visible to the eye. Yet it's there. Scientists call it the hydrogen wall. What is this hydrogen wall? Imagine the solar system as a boat sailing through a vast galactic ocean. Around the boat, waves of particles crash and swirl. The sun, constantly blowing out its solar wind, creates a bubble that keeps most of the galactic ocean at bay. But at the very edge of this bubble, interstellar hydrogen atoms, particles drifting in from the galaxy, pile up like sea foam along the bow of the boat. This pileup creates a glowing, invisible frontier. In 2018, NASA's New Horizons spacecraft, famous for its flyby of Pluto, looked back toward the edge of the solar system with a special ultraviolet instrument. And what it saw astonished scientists. A faint ultraviolet glow, a signature of hydrogen atoms spread across the sky. This was evidence that a hydrogen wall truly exists, wrapped around the heliosphere like a cosmic curtain. Close your eyes and imagine it. An unseen glow at the edge of everything we know. A glowing rim where the solar system presses against the galaxy. That's the hydrogen wall. Here's where the mystery deepens. This hydrogen wall shouldn't be permanent. The sun's solar wind fluctuates with its 11-year cycle. Sometimes the solar wind is strong, sometimes weaker. That means the size and pressure of the heliosphere should expand and contract like a beating heart. And if the bubble changes, the hydrogen wall should change too. Yet, the data suggests that the wall is more persistent, more stable than expected. Why? Could there be forces at play we don't fully understand? Let's break it down. Interstellar hydrogen atoms are neutral. They don't carry an electric charge. That means they can sneak past the sun's magnetic defenses. But once they reach the edge of the heliosphere, some of them collide with solar wind particles, creating a kind of traffic jam of atoms. This pileup is what creates the ultraviolet glow. The hydrogen wall isn't made of bricks or steel. It's made of atoms, compressed and slowed, marking the transition between our solar system and the interstellar medium. Think about the elegance of that. An invisible wall, not built by hands, but by physics itself. A natural barrier that shows us exactly where one domain ends and another begins. But it also raises profound questions. If this hydrogen wall exists, what does it tell us about the galaxy beyond? Could there be variations in the interstellar gas around us, shaping and reshaping the wall? And if the solar system moves into a denser interstellar cloud in the future, could the wall grow thicker, stronger, even more protective? Or could it collapse, leaving us vulnerable to the galaxy's raw energy? There's also the matter of cosmic rays. These high-energy particles, accelerated by supernovae and black holes, stream across the Milky Way constantly. They are dangerous, capable of damaging DNA, disrupting electronics, and altering climates. The heliosphere and its hydrogen wall block much of this radiation. Without them, Earth would be bathed in a storm of galactic energy. Life might have struggled to evolve the way it did. The very fact that you are here, listening to this story, may depend on this invisible shield. It's humbling, isn't it? To realize that survival on Earth has always depended not just on the sun, not just on the atmosphere, but also on a distant, unseen wall of hydrogen atoms, billions of kilometers away. And here's the poetic twist. This wall is glowing, not in visible light you can see with your eyes, but in ultraviolet. New Horizons detected it. The Voyagers felt its pressure. It's real. But no human will ever stand at its edge and look at it directly. It will always remain invisible to us, except through instruments, mathematics, and imagination. Yet, the fact that we can detect it proves something vital. Humanity is learning to read the hidden architecture of the cosmos. We are mapping the invisible. We are finding that the solar system isn't an open playground. It's a protected island, wrapped in a glowing boundary that holds back the storm of the galaxy. And so the question you have to ask is this. If there is a hydrogen wall, what lies beyond it? If our solar system is encased in a bubble, pressed against by interstellar gas, what does the other side look like? The Voyagers are there now, sending whispers from beyond the wall. But they can't see everything. Their instruments are old, their power fading. To truly understand this frontier, we need new explorers, new eyes, new technology. In the next section, you and I will explore those possibilities, the proposed missions that could map the invisible frontier in detail, missions that could finally answer the burning question: is the wall simply a pileup of hydrogen, or is it something even stranger? But for now, take this with you. The solar system is not naked. It is not drifting unprotected through space. It is shielded, guarded by an invisible hydrogen wall glowing faintly in the ultraviolet, standing as the last line between us and the galaxy beyond. You've already traveled with the Voyagers, touched the mysterious wall with them, and glimpsed the glowing hydrogen barrier through the eyes of New Horizons. But now, you might be wondering, what comes next? Because those spacecraft, as heroic as they are, were never designed to study the heliopause in detail. They gave us tantalizing hints, mysteries wrapped in streams of numbers. But to truly unlock the secrets of this invisible frontier, humanity needs new eyes. Think of the Voyagers as scouts, brave explorers with crude tools, stepping into the unknown. Now imagine the next generation, sophisticated probes built specifically to map the structure of the heliosphere and beyond. Missions that could tell us the shape of the invisible wall, its thickness, its strength, and even its connection to the wider galaxy. NASA has already been planning one such mission. It's called the Interstellar Probe. Picture it, a spacecraft far larger and more advanced than Voyager, launched with the express purpose of leaving the solar system at high speed. While Voyager took 35 years to cross into interstellar space, the interstellar probe could reach the boundary in just 15. Its instruments would be tuned to detect the structure of the hydrogen wall, the flow of interstellar plasma, and the shape of the magnetic frontier. Here's the exciting part. This mission isn't science fiction. Scientists and engineers have been sketching its designs for years. The idea is to launch it in the 2030s, using powerful rockets to push it out of the solar system faster than anything we've ever built. Imagine it, a probe traveling at nearly 100,000 kilometers per hour, racing toward the invisible shield. But why go to such lengths? Why pour billions of dollars into studying an invisible wall, billions of kilometers away? The answer is simple. Because it's more than a wall. It's a shield, a guardian, a filter that controls what kind of energy and particles enter our solar system. If you want to understand Earth's climate, if you want to understand the conditions for life, if you want to understand how habitable systems might form around other stars, you have to understand this shield. Now, let's step back and look at the big picture. The heliosphere, with its invisible wall, is not unique. Every star in the galaxy has its own version. Every star blows out stellar wind, creating its own bubble in the galactic medium. Some are strong, some weak, some shaped like comets, some distorted by nearby stars. By studying our own shield, we can begin to understand the shields of other stars and perhaps the protection they offer to alien worlds. That's the cosmic connection. By sending probes to study the hydrogen wall, we're not just learning about our solar system, we're learning about the galaxy itself and how life might survive within it. And here's another reason why these missions matter. The solar system is moving. Right now, we're traveling through a region of the galaxy known as the local interstellar cloud, a thin, wispy cloud of gas and dust. But this won't last forever. In tens of thousands of years, we'll drift into new regions of space where the density and pressure could be very different. That means the invisible wall guarding us could change. It could grow stronger, it could weaken, it could even collapse entirely. Understanding it now may help us predict what will happen when our sun's shield faces new galactic conditions. Now imagine yourself as part of the team designing this interstellar probe. You're holding blueprints, looking at instruments capable of detecting ultraviolet glows, magnetic fields, and cosmic rays with precision never before achieved. You know the mission will take decades. You may never see its full results in your lifetime. Yet, you press on, because discovery is not about instant gratification. It's about building a bridge for future generations. Think about the symbolism here. The Voyagers carried a golden record, a message from humanity. The interstellar probe will carry something different: knowledge, data, proof that we dared to study the invisible, that we wanted to know what shielded us, that we sought to understand our place in the galaxy, not just with imagination, but with science. And here's where it gets emotional. Imagine the launch day. The rocket thunders into the sky carrying the interstellar probe. Somewhere, children watch it on TV, not fully realizing that this spacecraft is beginning a journey that will outlive them, their children, and their grandchildren. A journey that will reach beyond the solar system and into the vast ocean of stars. A journey to study a wall that no eye can see, but that every breath of air on Earth depends upon. That's what makes these missions so powerful. They're not just about science, they're about legacy, about courage, about humanity's refusal to accept the boundaries of the unknown. And so, as we stand on the brink of a new age of exploration, you have to ask yourself, what will we find when we send new eyes to the frontier? Will the hydrogen wall glow brighter, revealing its secrets? Will we discover new structures, new shapes, new defenses we never dreamed of? Or will we find cracks, weaknesses, vulnerabilities that remind us just how fragile our cosmic shield really is? In the next section, we'll take this even further. We'll dive into the strange and surprising ways the invisible wall interacts with the galaxy beyond. Because as protective as it is, this shield also hides something shocking: a constant war between the sun and the Milky Way. And you are caught in the middle of it. Now imagine this. You're standing on a cliff, waves crashing below, the wind howling in your face. The land behind you is calm, protected. But out on the horizon, storms rage endlessly. That's the perfect metaphor for what happens at the edge of our solar system. The invisible wall, the hydrogen wall, the heliopause, isn't just a quiet boundary. It's a battlefield, a place where the solar wind and the galaxy collide in a constant silent war. The sun is not just a ball of light warming Earth. It's a furious engine, hurling out streams of charged particles at hundreds of kilometers per second. This solar wind races outward in all directions, filling the solar system with a magnetic bubble, the heliosphere. Inside this bubble, the sun is king. Its magnetic field rules, its particles dominate. But the sun's power doesn't stretch forever. Eventually, it weakens. And beyond that weakening lies the galaxy, a river of cosmic rays, interstellar plasma, and magnetic fields shaped by stars long dead. The clash happens at the invisible wall. Think of the solar wind like a flood rushing down a valley. Now imagine another flood pushing in from the opposite side. Where they meet, chaos erupts. The heliopause is that meeting place. On one side, solar wind particles push outward. On the other, interstellar particles push inward. The result is a shifting, wrinkled, dynamic frontier. The sun is constantly defending its territory, while the galaxy constantly pushes back. This is why Voyager 1 and Voyager 2 recorded such different crossings. They didn't pass through a neat, simple border. They passed through a war zone. At Voyager 1's location, the solar wind had thinned dramatically, allowing cosmic rays to surge inward. At Voyager 2's point, the balance was slightly different. More plasma, a thicker shield, a different kind of resistance. The wall isn't static, it's alive, changing with the solar cycle, with the pressure of interstellar gas, with the ripple effects of supernovae that exploded millions of years ago. Yes, supernovae. That's the galaxy's weapon. When stars explode, they fling out shockwaves that ripple across interstellar space for millions of years. These shockwaves carry magnetic fields and particles that eventually slam into the heliosphere. When they do, they squeeze the bubble, press against the hydrogen wall, and alter the shape of the invisible frontier. Imagine a balloon being pressed by invisible hands. That's what the solar system feels all the time as it sails through the Milky Way. And here's the part that really makes your skin tingle. The solar system is moving at 828,000 kilometers per hour around the center of the galaxy. That means we are constantly plowing into new regions of space where the density of gas and magnetic fields changes. Right now, we're inside the local interstellar cloud, a relatively calm, thin patch of gas. But what happens when we leave it? What if, in 50,000 years, we enter a denser region? The invisible wall might grow thicker, stronger, more protective, or it might collapse under the pressure, letting deadly cosmic rays flood in. The fate of Earth's biosphere could literally depend on what kind of galactic environment we drift into. That's why scientists call the heliopause not just a shield, but a filter. It doesn't block everything, it lets some cosmic rays through while deflecting others. The balance between the sun and the galaxy determines how much radiation makes it into the inner solar system. Too much, and satellites could fry, astronauts could suffer dangerous exposure, and even climate systems on Earth could shift. Too little, and ironically, life might evolve differently, shaped by the absence of high energy sparks that sometimes drive genetic mutation. So, yes, the invisible wall is more than a boundary. It's the front line of a cosmic struggle. A war you never see, but one that touches every moment of your life. Let's get even more vivid. Imagine yourself a cosmic traveler moving toward the edge of the solar system. At first, everything is quiet. The sun dominates. The planets orbit in calm harmony. But as you approach the heliopause, you feel turbulence. Invisible winds crash together. A wall you cannot see, but it's there. You drift in your imagination, far away from the comfort of Earth, past the buzzing satellites and the orbiting space stations, into the quiet abyss of interplanetary space. At first, it feels endless, like an infinite ocean of nothingness. But then you learn something astonishing. This emptiness isn't as open as it seems. Somewhere out there at the edge of our solar system lies a barrier, a wall. Not a wall of bricks or steel, not even a glowing sci-fi force field. No, this is an invisible wall. One you cannot touch, one you cannot see, but one that seems to hold everything inside. And here's the unsettling truth. It may be protecting us or hiding something far stranger. When scientists first hinted at its existence, the news was buried beneath the usual noise of headlines. But this discovery, quiet as it was, could change the way you see the universe forever. Imagine traveling billions of miles from the sun, your spacecraft powered by decades of engineering brilliance, carrying humanity's curiosity across the void. Then, suddenly, it begins to act differently. Data becomes strange. Some unseen boundary is interfering. That's exactly what happened with NASA's Voyager probes. You see, back in 1977, two spacecraft, Voyager 1 and Voyager 2, were launched to study the outer planets. They were not just robotic observers, they were ambassadors of Earth, carrying golden records, engraved with sounds of our world, in case alien civilizations ever stumbled upon them. But beyond their mission to Jupiter, Saturn, Uranus, and Neptune, the Voyagers were also destined for something far more ambitious, to pierce through the edge of the solar system and step into the space between the stars. And it was there at the boundary where things began to change. Scientists noticed that as the probes pushed outward, something invisible pressed back, a kind of cosmic resistance, a pressure, almost as if they had reached the skin of a bubble surrounding everything we know. Imagine that, our solar system wrapped in a vast unseen cocoon. It sounds like science fiction, doesn't it? But it's not. It's very real. This invisible wall isn't built of stone or metal. It's created by forces far greater: charged particles, magnetic fields, and the relentless wind of our sun clashing with the interstellar medium. Together they form the heliopause, a frontier where the solar wind loses its strength, giving way to the wild winds of the galaxy beyond. And yet, when Voyager crossed it, scientists saw something baffling. Energetic particles from our own sun weren't just bleeding out into the galaxy the way they expected. Instead, they seemed trapped, bottled up, bouncing back, as though some unseen wall was reflecting them inward. You pause for a moment and think, why? What is this wall really made of? And what does it mean that our entire solar system is inside it? The more you think, the stranger it feels. Because if there's a wall, then in a sense, we're living inside a cosmic prison. Or maybe, just maybe, we're living inside a shield. This discovery wasn't just about physics, it was about perspective. For thousands of years, humans have looked up at the night sky, imagining endless freedom beyond. But this finding whispered something different. Our home system is wrapped, contained, separated. The infinite cosmos isn't as open as it first seemed. There's a threshold, and crossing it is no easy thing. Think about it. We humans dream of interstellar travel, of sending ships to other stars. But long before we can even attempt such a journey, we face this barrier, and the more scientists studied it, the more mysterious it became. Was it simply magnetic turbulence? Was it layers of compressed plasma stacking up like invisible curtains? Or was it something we couldn't yet imagine, a structure created not just by physics, but by design? That last question sends a chill down your spine. Because if this wall isn't natural, then who or what put it there? Of course, most scientists stick with natural explanations. The sun's magnetic field pushes outward, colliding with the galaxy's magnetic currents, shaping this bubble we call the heliosphere. It makes sense. It's logical. But logic doesn't erase the wonder. Even if it's just physics, it's still breathtaking to realize we're wrapped inside an invisible shield, a barrier that protects Earth and every planet from dangerous cosmic radiation and energetic particles. Without it, life as you know it might never have flourished here. And yet, deep down, a question lingers. Is it truly just protection, or is it also confinement? You feel the tension between safety and entrapment, like living inside a house with strong walls. They guard you from the storm outside, yes, but they also keep you in. The Voyagers sent back more than numbers. They sent back a revelation that out there, at the edge of everything we know, reality isn't simple. The cosmos doesn't open up like a plain road. Instead, it greets us with a frontier, a liminal space where the familiar laws of the sun fade and something else begins, something alien. And that's just the start. Because as you dive deeper into this mystery, you'll realize the invisible wall is more than a boundary. It's a riddle written in particles and fields, one that dares us to solve it, and maybe, just maybe, one that hints at truths about the universe we are not yet ready to understand. So take a breath. Let the thoughts settle in. You live in a solar system with a wall, a mysterious, invisible wall. And tonight we begin the journey to uncover what it really is, why it matters, and how it could change humanity's future in ways you've never imagined. The Voyager probes and the first signs of the wall. You sit with the image of the invisible wall in your mind, still wondering how such a thing could exist. To understand it fully, you need to step back into the late 1970s, a time when disco filled the air on Earth, but far above the atmosphere, two small spacecraft were leaving home forever. Their names? Voyager 1 and Voyager 2. These weren't massive starships or sleek futuristic rockets. They were modest, bus-sized explorers powered by plutonium hearts, carrying dish antennas like shields and golden records that sang the story of humanity. You picture it, engraved copper discs carrying whale songs, greetings in 55 languages, and the hum of wind, rain, and bird song. It was a time capsule, a hopeful message to the cosmos. We were here. We existed. We dreamed of meeting you. But beyond their poetic cargo, the Voyagers had a far more serious mission: to journey outward, across the planetary frontier, and eventually to the very edge of the solar system. No one truly knew what they would find there. You imagine them cruising past Jupiter, its swirling storms flashing like a furious eye, its volcanic moon Io spitting fountains of fire into the void. Then, Saturn, with its rings shining like a cosmic crown. Then Uranus and Neptune, icy blue giants drifting in silence. Each encounter rewrote textbooks, stunned scientists, and reminded you how small Earth really is. But even after these triumphs, the Voyagers kept going, and that's when the real mystery began. For decades, they traveled onward, powered by nothing more than momentum and patience. And then, around 2012, Voyager 1 finally reached something extraordinary: the edge of the heliosphere, the great bubble carved out by the solar wind. At first, scientists expected a simple transition. They thought the spacecraft would pass cleanly from the domain of the Sun into interstellar space. But that's not what happened. Instead, Voyager 1 reported something strange. Particles from our own sun weren't dispersing into the galaxy as expected. Instead, they seemed to be reflecting, bouncing back, as if something was pushing them inward. You lean in closer, imagining the data streams reaching Earth, numbers flashing across NASA's control screens, confusion, debate. Then the dawning realization: there is an unseen barrier here. And this wasn't just a blip. Voyager 2, crossing years later in 2018, confirmed it. Once again, charged solar particles behaved in ways that defied predictions. It was like hitting a cosmic force field, one you couldn't see or touch, but could measure in every reading. Scientists tried to describe it. Some said it was a magnetic wall, created as interstellar magnetic fields pressed against our heliosphere. Others suggested it was a dense region of plasma, where solar winds slowed, compressed, and tangled. Still others wondered if something far stranger was happening, something we simply didn't yet understand. Imagine that feeling: the boundary of your entire world not being what you thought. For generations, people imagined space as wide open, but the Voyagers revealed it isn't open at all. It's structured, shaped, contained. You pause to think about the scale. Voyager 1 is now more than 14 billion miles away. That's 150 times farther from the sun than Earth is. And even there, so far beyond anything you can see in the night sky, the influence of our sun still lingers. The heliosphere stretches like a balloon, keeping out much of the galaxy's radiation, shielding our fragile biosphere. That's why some scientists say this wall is not just strange, it's vital. Without it, Earth might have been bombarded with deadly cosmic rays for billions of years. Without it, life may never have had a chance. But here's the unsettling part. While this invisible wall protects us, it also challenges us. Because if humanity ever hopes to leave the solar system, if we want to send crewed ships to other stars, we must first learn how to cross it. And right now, we don't fully understand what it even is. Some researchers describe the Voyager findings as like a bug hitting a windshield. The probes, tiny as they are, slammed into a resistance that shouldn't have been so strong. Why was the wall denser than predicted? Why did particles bounce back so sharply? And why does it almost feel designed? Of course, the official explanation leans on physics. The sun's magnetic field collides with the galaxy's own magnetic environment, and the clash creates turbulence. Picture two oceans crashing together, their waves building a chaotic ridge. That ridge is the wall we've found. But deep down, you can't shake the thought that something so vast and so strange could hold secrets beyond physics. This is where imagination takes over. Some whisper, what if the wall is a filter? What if it allows certain things through and blocks others? What if it's not just a shield, but a gate? When Voyager 1 crossed it, the sun's particles changed dramatically, but the interstellar particles outside seemed to shift too, as if the boundary influenced both sides. It wasn't just a line on a map, it was an interaction, a negotiation between our solar system and the greater galaxy. And you realize, maybe this isn't just a wall at all. Maybe it's a frontier, a living frontier, one that breathes with the sun's activity, expanding and shrinking with the solar cycle, shaping the way our home meets the infinite beyond. That thought excites you and unnerves you all at once, because it means we're not just passengers in a galaxy. We're residents of a cosmic neighborhood with boundaries and borders. And like all borders, this one comes with both protection and questions. The Voyagers, even now, continue to send back whispers from the edge. Their power is fading, their signals weakening, but each piece of data they beam back is another clue in the puzzle of this invisible wall. And as you sit here, you can't help but wonder, if such a wall exists here, could other stars, other civilizations be wrapped in walls of their own? Could the galaxy be a patchwork of bubbles, each shielding its children? You feel the weight of it. Humanity has only just begun to touch the edges of its own bubble. And beyond that, the unknown. A frontier wrapped in mystery, daring us to step outside. The solar wind and the shaping of the bubble. Close your eyes and picture the sun, not as the gentle golden disk you see in the sky each morning, but as a roaring furnace. Beneath its surface, nuclear fusion rages. Every second, millions of tons of hydrogen fuse into helium, releasing energy that has kept Earth alive for over 4 billion years. But the sun doesn't just give off light and warmth, it breathes. And its breath is powerful. This breath is called the solar wind, a steady stream of charged particles that surges outward in all directions. Imagine standing beside a hurricane, but instead of air, it's made of electrons and protons. The solar wind never stops. It rushes outward at speeds of up to 1,000,000 miles per hour, flooding the solar system, shaping the environment of every planet you've ever known. Earth, with its magnetic field, bends this storm around itself, creating the shimmering auroras you've seen dancing in the polar skies. Mars, with its weak magnetism, has been stripped of much of its atmosphere by this same relentless wind. Even Jupiter, mighty as it is, feels the constant pressure. But as fierce as the solar wind may seem here, it isn't infinite. The farther it travels, the weaker it becomes, like breath dissipating into a vast room. Eventually, it collides with the material that fills the galaxy itself, the interstellar medium. This medium is an empty space. It's made of tenuous gas, dust, and magnetic fields drifting between stars. To you, it seems like nothing. But to the solar wind, it is resistance. And this clash, the push of the solar wind against the pull of the galaxy, creates something extraordinary: the heliosphere. Think of it as a vast bubble. Inside it, the sun rules. Its wind blows freely, carrying solar particles across billions of miles. Outside it, the galaxy takes over. Its own particles, its own magnetic tides, press inward. The boundary where they meet, the place the Voyagers discovered, is the wall, the mysterious invisible wall that guards our solar system. Now, here's the part that truly makes you pause. This bubble is colossal. From the sun to the heliopause, the outer wall, it stretches more than 10 billion miles in every direction. To put it in perspective, if Earth were a single grain of sand, the heliosphere would be a football stadium enclosing it. That's how small we are inside this structure. But what fascinates scientists is the way the heliosphere moves and breathes. It isn't a static shell. It changes with the sun's moods. When solar activity rises, when sunspots boil and solar flares erupt, the solar wind strengthens, pushing the wall outward. During quieter periods, it weakens, allowing the galaxy to press in. The size of our protective bubble literally expands and contracts like the lungs of a living creature. You think about that, your home star breathing against the galaxy itself. Every inhale and exhale reshaping the frontier of your existence. It's both poetic and humbling. But here's where the story turns strange again. According to models, the heliosphere should be smooth, like a soap bubble. Instead, Voyager's readings suggest it's turbulent, that chaotic, filled with ripples, folds, and strange magnetic eddies. It's as if the wall isn't a perfect shield, but a stormy frontier, bristling with invisible currents. And yet somehow, this stormy wall still protects you. Cosmic rays, high-energy particles born in violent supernovae and distant black holes, are some of the most dangerous travelers in the galaxy. Left unchecked, they would bombard Earth, strip atmospheres, damage DNA, and threaten all life. But the heliosphere deflects many of them. It filters, weakens, and scatters these intruders before they can flood into our system. Think of it as the galaxy's version of a castle wall. Inside, we live and thrive. Outside, chaos reigns. And without this barrier, Earth may never have stood a chance. But here's the mystery: this wall doesn't behave exactly like scientists expect. In some places, cosmic rays seem trapped, caught bouncing back and forth. In others, they slip through more easily than predicted. And still, Voyager found something baffling. Certain solar particles refused to escape. They clung to the inside of the wall, as if something beyond was reflecting them inward. That reflection haunts the scientific community. It's like finding a one-way mirror in the wilderness. What is on the other side, holding particles back? Is it simply interstellar magnetism compressing harder than we imagined? Or is it something more structured, more intentional? For now, the safer answer is magnetism. Galactic magnetic fields, invisible and powerful, shape the wall into a barrier that behaves more like a shield than an open door. But still, you can't help but wonder, if you were to stand there on the edge of the heliosphere, would you feel it? Would you see the glow of compressed plasma? Or would it be utterly invisible, like a silent guardian keeping watch over everything you've ever known? The truth is, no human has ever seen it. No camera has ever captured it. It exists only in data, in models, in numbers plotted on charts, yet its reality is undeniable. We live inside a protective bubble, one created by the breath of our star, one that separates us from the cold, harsh galaxy outside. And in that realization, something clicks for you. This isn't just a wall, it's a story of survival. For billions of years, Earth has flourished in part because this barrier shielded it. Every life form that has ever lived, every breath you've ever taken has happened under its protection. Without it, the history of life might never have unfolded the way it did. But now, for the first time in human history, you know it's there. You've touched its edge through the eyes of Voyager. And with that knowledge comes new questions, deeper questions. What lies beyond? What happens when we finally step outside the bubble into the true void of interstellar space? The answer isn't simple, because beyond this protective wall, the galaxy waits, and the galaxy is not gentle. Beyond the wall, the galaxy is not gentle. You've now come to see the invisible wall as a kind of shield, a guardian wrapping itself around the solar system. But shields are only built when there is danger. And beyond this wall, the vast, open galaxy, is danger of a kind you can hardly imagine. The first threat comes from cosmic rays. Don't think of them as gentle beams of light. Cosmic rays are bullets, tiny fragments of atoms, protons, and nuclei, accelerated to near the speed of light by the most violent events in the universe. Supernova explosions hurl them across the galaxy. Black holes whip them outward in furious jets. Entire galaxies spew them like sparks from a cosmic fire. Now imagine standing outside the heliosphere, beyond the sun's protective breath. You'd be immersed in a storm of these high-energy particles. They'd slice through your body, smashing into your DNA, tearing cells apart at the molecular level. No shielded spacecraft would protect you for long. Even the walls of a space station would be no match. Without protection, life outside the heliosphere becomes nearly impossible. And yet, here on Earth, you are safe. Why? Because the invisible wall, along with Earth's own magnetic field and atmosphere, deflects and filters these deadly travelers. You owe your very existence to this unseen guardian. The second danger is more subtle: interstellar gas and dust. The galaxy isn't empty. Between stars lies a thin fog of hydrogen, helium, and microscopic grains of dust. To you, it may seem insignificant, but to spacecraft, it's resistance. To planets, it's erosion. To fragile atmospheres, it's a constant challenge. Imagine Earth drifting naked in the interstellar medium, its atmosphere slowly stripped by constant collisions. Life would not last long. And then there's radiation. The interstellar medium glows faintly with energy from ancient stars. It hums with the leftovers of violent events, shock waves, magnetic turbulence, and ultraviolet light. Beyond the heliosphere, all of that flows freely. Step outside and you are exposed to the raw chaos of the galaxy. You realize now why scientists speak of the heliosphere with reverence. It's not just a boundary, it's a sanctuary. For billions of years, it has cushioned Earth from the worst the galaxy has to offer. Without it, evolution itself might have been stunted, life never moving beyond primitive forms. In a sense, you could say the heliosphere is as essential to life as the sun's warmth or Earth's oceans. But this protection isn't perfect. Cosmic rays do leak through. In fact, some scientists believe these intrusions may have shaped life in profound ways. Think about it. Bursts of cosmic radiation may have triggered mutations in DNA, driving evolution forward. The very complexity of life might be, in part, a gift from the dangerous universe outside. The wall protects, but it also lets just enough chaos through to spark creativity in nature's design. And yet, for all its gifts, the wall remains deeply mysterious. Voyager's instruments told us that beyond the heliopause, cosmic rays are stronger, more chaotic, and more unpredictable. It's like stepping from a calm shoreline into a stormy ocean. Inside the bubble, life flourishes. Outside, survival becomes a fight. Now pause for a moment. Imagine humanity's dream of star travel. Imagine launching a ship, not just to Mars, not just to the outer planets, but beyond, to Alpha Centauri, the nearest star. Before you can even attempt it, your ship must cross this invisible frontier, and once it does, the crew is no longer protected. They would sail directly into the storm of the galaxy. How do you shield human bodies from such radiation for decades, even centuries of travel? Lid walls would be too heavy. Magnetic shields may be possible, but the technology is untested. For now, the invisible wall stands as the first great obstacle between us and the stars. And yet, there is beauty in this danger, because it reminds you that space is not empty, it is alive. It is violent, yes, but also creative. Cosmic rays may be killers, but they also carry information, stories of the universe's most powerful engines. Every particle that slams into the heliosphere is a message from a star that exploded millions of years ago, from a black hole that tore matter apart in a galaxy far away. The wall doesn't just shield us, it filters the whispers of the cosmos, letting us catch them, study them, and learn. But here's the most haunting thought. If the heliosphere protects us, then what happens when it fails? What happens when the sun changes, when the wall shrinks, when Earth is more exposed to the galaxy's fury? There is evidence that such things have happened before. Periods in Earth's history when cosmic rays surged, when radiation levels climbed. Some researchers even link these cycles to changes in climate, mass extinctions, or bursts of evolutionary growth. It's unsettling to think that our safety is not absolute, that the wall breathes, shifts, and sometimes weakens. And yet that's the truth. The barrier is not permanent. It is fragile, dynamic, alive with the pulse of the sun. So here you are inside your bubble. The galaxy outside is violent, unforgiving, filled with storms of radiation, dust, and chaos. And yet here on Earth, you live under blue skies with oceans that sparkle, with forests that breathe. All of it possible because of a wall you cannot see. Take a moment to let that sink in. Every heartbeat, every memory, every story humanity has ever told has unfolded under the watch of this invisible guardian. You are not just a resident of Earth, you are a child of the heliosphere, and beyond its edge lies the raw, unfiltered truth of the universe. The Voyagers brushed against that truth. They felt the storm outside, and what they discovered left us with awe, with questions, and with a renewed sense of how precious this shield truly is. But the story doesn't end there, because even as we marvel at the wall's protection, we are forced to ask, what exactly is it? What is its structure? How does it reflect particles? And could it be more than a natural shield? Could it be something designed?